Now let's talk about the transpose of a matrix or vector. So let's start with an example. It's easier to understand that way. If I have A is equal to this matrix, 1, 2, 3, 4, 5, 6, then A transpose, so we write it as if A was raised to the capital T power, will be equal to this. Right? So basically, if you think about the main diagonal of your matrix, you flip about that diagonal. So the rows become the columns, and the columns become the rows. Okay? And we could do that with vectors as well. So if we have X is equal to the column vector, 7, 8, 9, then X transpose will be the row vector, 7, 8, 9. Okay? That's all there is to the transpose. So rows become columns, columns become rows. If the matrix happens to be square, doesn't really matter. 1, 2, 3, 4. Then B transpose is 1, 3, 2, 4. Right? I just take the diagonal, flip around the diagonal, so this row becomes first column, second row becomes second column, and so forth. So let's look at some properties or rules that involve transposes. Some of these are self-evident, some aren't. So the transpose of the transpose of a matrix is equal to the original matrix. So the transpose of the transpose of A is just back equal to A. That makes sense. B. If I add two matrices, A plus B, and this assumes that these have the dimensions that allow the addition, otherwise it doesn't matter. We wouldn't be able to do that. And then take the transpose of that answer. Well, that's equal to just transposing A first and adding it to the transpose of B. Okay? Third one. If I scale a matrix A by a scalar K and then take transpose that result, that's just the same thing as transposing A and then scaling by K. Now to me, each of these makes sense, and you could sit down and work some examples and see why things have to be the way they are. The last one's not so obvious. Okay? And that says, if I have matrices A and B whose dimensions allow me to produce their product, so if I can't produce AB, nothing else matters, and then I transpose that, that's equal to B transpose times A transpose. This is one that's less obvious to me. Okay? So once again, what does it say? We'll apply A times B, then take the transpose of that matrix, and that's equal to the transpose of B times the transpose of A. Okay? So there's the transpose.